So, hello and welcome to a new lecture on statistics. The scope of today's lecture is to introduce the concept of uniform distributions. And we saw in previous lectures that a distribution is in general some kind of function that describes how many times an outcome of a certain random experiment is obtained on average. And we also saw that if we ask for the number of times a certain outcome is obtained in a random experiment on average, that this concept is closely related to the concept of what is the probability of the outcome in this particular random experiment. And today we are discussing uniform distributions, which are a very special kind of distributions. They are uniform in the sense that the probability of the outcome is the same for every different outcome that can be obtained in a very particular random experiment. And the two typical examples of random experiments are, of course, the role of a fair die. So a die has 6 different faces, and if it is a fair die, all the faces are equally likely to be obtained when you roll the die. And the other experiment, of course, is the flip of a fair coin, where you basically have tails and heads, and if the coin is fair, then you can obtain, when you flip the coin, both sides also equally likely. So let's start with the roll of a die. And the roll of a die is actually characterized by 6 random variables. So the outcomes of the roll of a die. So you can basically have the 6 different faces and their associated probabilities. And if you obtain, for instance, x equals 1, so the phase 1, the associated probability is 1/6. And of course, this is the same as it is a fair die. If you obtain the outcome x equals 2, the associated probability here again is 1/6. And so on and so forth. For x equals 3, same probability. X equals 4, probability is as well 1/6. And x equals 5, probability is 1/6. And x equals 6, of course, the same result, 1/6. And the distribution can, in this particular case, be easily represented by a probability mass function. And a probability mass function has in general 2 axes. You have a y-axis and an x-axis. On the x-axis, you put the random variable x, and you here, in this particular case, you have 6 different values. So you have 1, you have 2, 3, 4, 5, and 6. And at the level of the probabilities, you have the same probability, of course, because it's a uniform one, for the 6 different random variables. So 1/6, so we are basically somewhere here. So for the first one, you are here. X equals 1. X equals 2, you are at the same level, of course, same probability level. I forgot to put here that on the y-axis, you, of course, have the probabilities. X equals 3, same story. X equals 4, 1/6 as well. X equals 5, 1/6. And x equals 6, again, probability 1/6. And that's basically one of the typical examples of having a uniform distribution, which is characterized by a probability mass function, where all the different outcomes and all the associated random variables have the same probability. In this particular case, 1/6. And of course, it is important to check if the sum of all the different probabilities of the different random variables of this random experiment sum up to 1. And this is the case, of course, because we have 6 different random variables, and if you multiply 1/6 by 6, you obtain, of course, 1. So it's a total probability of 100%. The other typical example, of course, is even easier because you only have 2 random variables, which is the flip of a coin. And here again, you can basically represent this by the corresponding probability mass function. So again, you have on the y-axis the probability, and on the x-axis you have the random variable. And in this time we ask, what is the probability to obtain tails? And so basically you can obtain heads when you flip the coin, and then you have 0 times tails. So you have as a random variable 0, or you can flip the coin and obtain tails, and then you have 1 time tails, of course. And the associated probabilities here, of course. So basically you can have x equals 0 for 0 times tails, with associated probability p of x, of course, 1/2, because it's a fair die. and you can have x equals 1 with having 1 time tails, an associated probability p of x equals 1, here I should put 0, is of course again 1/2. So here in this level we have 1/2, for instance here, and we have the probability of not obtaining tails when we flip the coin, which is 1/2, and again same probability to obtain tails when we flip the coin, and we obtain tails in this particular case. So what you see is for uniform distributions, you have of course a uniform probability distribution, which means that you have the same distribution, you have the same probability for each of the random variables that can take place in a very particular random experiment. So this concludes the discussion on uniform distributions. If you have questions, please leave a message in the comment section below. And if you want to have additional explanations on these particular topics, then please leave me a message as well in the comment section. Don't forget to subscribe to my channel in order not to miss new lectures and new videos. And see you in the next video.